This is a quote of the day. It's from an author by the name of Seth Godin. Here's what we're teaching kids to do with various levels of success: fit in, follow instructions, use number 2 pencils, take good notes, blah, 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 blah. I want to go down to the bottom. It says, now the key questions. Which of these attributes are the keys to being indispensable? Are we building the sort of people our society needs? And Godin goes on to say that we should really be teaching just 2 things in school. Number 1 is solve interesting problems. Number 2 is lead. Now, leading is such a hard thing to teach, so I'm not going to teach it in this video, but I do want to show you some interesting problems. And I think these are interesting. If you think about somebody that puts together furniture or tears it apart, or somebody that looks under the hood of a car, fixes a tire that's flat, you're talking about somebody that is well adept at transforming things and seeing them for what they aren't, and then having the vision. They're really artists to put them together again. So I want to be an artist here, and I know that you might think I'm exaggerating, but I think that that's what we're doing here. And people always ask, why do we have to learn this? I think this goes back to Seth Godin's interesting problem idea. If you can solve interesting problems, you've got a bright future. So this is the factored form, and we're going to go into standard form. So if I was to write this in standard form, we would multiply the x's together, right? Hopefully we're familiar at this point. That's going to be x squared. 9 times x is going to be 9x. We would subtract 4 of the x's because that's a negative 4. And 9 times negative 4 is negative 36. And from there, we could, of course, combine the like terms and say that this is x squared plus 5x minus 36. And we could even take this further apart. Anna Kendrick, not Anna Kendrick, the math student, who's an outstanding math student. Shout out Anna Kendrick. I would say Anna Kendrick, the movie from Pitch Perfect. You guys know what I'm talking about. She was able to take cups and turn them into musical instruments. That right there is creative problem solving. It's seeing an object not for what it is and transform it. She made what was it, the Glee Club, or what do they call it, the a cappella group at the school? I've seen the movie 10,000 times in that stupid bus to D.C. Thank goodness. That's one good thing that I didn't have to do this year with you guys, is see that stupid movie. But it's x squared plus 5x. Imagine this was an equation here, and it said equals 0. What I could do is add 36 to both sides, and now I'm seeing the equation for something that maybe I never saw it for over here. Of course, this would have to equal 0 at the beginning. The reason that I'm showing you this, again, is just so that you can start to see things and tear them apart, put them together again. That's what doctors are doing when they search for cures for diseases. They're trying to take apart the disease, take it out of its natural environment, see what happens when you change temperatures, when you add oxygen to it, when you take away oxygen from it. We're just seeing this in different forms, so this is another way to look at it. And this right here, by the way, this would be called non-standard form because it's not set equal to 0. So you're going to see that on the upcoming Google form, but that's what it is, non-standard. Standard meaning you've got the degrees in order, so the degree of 2, then the degree of 1, and finally the constant term, which is right here, a degree of 0. So this is non-standard because we don't have them actually written with a constant as part of the overall polynomial. Let's just say we had to go from standard form to factored form. So you're putting the car together, right? And we're trying to see things for different parts and see them in isolation, right? So x squared plus 10x plus 16. Well, I know that the last term here is 16, and 4 times 4 gets me 16. So I could just write x plus 4 and then write x plus 4 again. And I knew to write x as well because it was x squared right here. You had to multiply x times x. And if you do that, your middle term here is 4 times x, which is 4x. And your other middle term is another 4x. And of course, I've got my 4 times 4, which is 16, and my x times x, which is x squared. That's not getting me 10x. So there's got to be another way that I can multiply these 4s and get 16. So, well, we could do 8 times 2. We could also do 16 times 1. And then 4 times 4 we already discussed. So let's try 8 times 2. If we do x plus 8, Again, I'd get 16 for my last term, and I would get x squared for my first term. It's just a matter of what's in the middle here. 8 times x is 8x, 2 times x is 2x, so I end up with 10x, and that's what I wanted the whole time. So it looks like to get to factored form, what I needed to do, and this is answering the question, is this right here. That's factored form. And if you want to, pause the video right now and see if you can do it on your own. That's where you're truly going to learn stuff and where you're going to learn to use the cups as your musical instrument, right? So I can see I got 12, so I'm thinking that 12 is 4 times 3, b plus 4 and b plus 3. So as I do that, that's b squared plus 4b plus 3b plus 12. And that equals 7b, so that's not what we wanted. So it's not 4 times 3. Let's try 6 times 2. So I got b squared. I got 6b right here. Maybe I should be using different colors. Hopefully you're able to pick this up. That's a 2b right there. And then, of course, the last term here is 6 times 2, which is 12. And so we get b squared plus 8b. I've distributed everything, and it looks like it's the same expression I have up here, the same polynomial, trinomial really, but this is a minus sign and this is a plus sign, so the absolute value is different here. If you pause for a moment and think, how do you get 12 still, but make this a negative 8b, hopefully you realize you could change this to a minus 6 and this to a minus 2, because negative times negative is going to get you a positive. So let's do this in green just so this stands out. So you can see I multiplied b times b, obviously got b squared there. Then I did negative 6 times b and I got negative 6b. I did b times negative 2 and I got negative 2b. And then negative 6 times negative 2 gave me positive 12. If you combine these negatives here, they're like terms, that's what gets you negative 8b. And that's what we had up here. So yeah, this right here, negative values will get you your negative coefficient of 8 right here. One more for us, and then we'll look at kind of the general pattern that we're seeing here. I've got an r, so I know that that's going to be my first term. I'm going to start off with this and this, so I've got a little template going on. And then I need to get 24 right here, but it's a negative 24. So that must mean that one of these is positive and one of these is negative, since I have to multiply a positive by a negative to get 24. Let's try 6 times 4. So if I do that, I get 4r for this middle term. And then on the other side, negative 6 times r, I get negative 6r. And so one thing I notice right away here, I get negative 2r. So of course it's not going to be positive 4 and negative 6. But I also don't want this to be negative. I want this to be positive. So this became a negative, I think, because the negative was a bigger value. It had more absolute value than the positive over here. So let me switch those around. All right, and I'm going to use an orange here because I'm under construction. If I had put the positive 6 right here and the negative 4 right here, I would get 6r and then, of course, negative 4r. This looks like a St. Patrick's Day parade or something. So we've got 2r, and it's positive now, which is good because we need this to be positive, but unfortunately, we don't want there to be a difference of only 2 between these. We want there to be a difference of 5. So if you think about 6 times 4, we got 2r, and it looks like 6 and 4. How did we get 2 with 6 and 4, right? Another way to get 24 is 8 times 3. Another way is 12 times 2, or even 24 times 1. Now, if you look at 8 and 3, that's tempting because I know I can get 5. The same way maybe I did 6 minus 4 to get 2, I could get 5 using 8 minus 3. So let me try those. And once again, I've proven that the positive value, it needs to be bigger than the negative value. So I'm going to put the 8 over here, and the 3 I'm going to put over here because I want that positive value to win out, right? Win the battle here. So 8 times r is 8r. Negative 3 times r is negative 3r. And 8r minus 3r is 5r. So we end up with 5r here, and the rest will already work out because we already figured out 8 times negative 3 will get us negative 24, and r times r is r squared. So this is your final answer right here, r plus 8 times r minus 3. So just trying to summarize this generally, this is the way that mathematicians typically describe what we just saw. They say this is an equation x squared plus bx plus c. So You notice x squared right here doesn't have a coefficient. In any of these problems, we didn't have a coefficient to start with, r squared. And then there was a coefficient in front of this middle term. And that was different in each one, and there was a lot of ways to come up with it. You had 5 in that one, and 8, negative 8, excuse me. What we say is we could multiply these two numbers, p and q, where p times q is going to equal c, and we saw that throughout. I did 8 times negative 3, and I got this value. And negative 6 times negative 2, and we got this value. But you notice it was a little bit of a struggle to get that value. We tried 4 and 3. We tried positive 6 and positive 2. Over on this one, remember we tried 6 and 4. We struggle a little bit to get there. And so if you want to avoid that struggle, all we need to do, and we talked this a little bit on the last one, if you add those two values, p and q, you get c. And you might be confused. You're saying to yourself, you didn't add these. You did 8 minus 3 to get 5. But think of the minus 3 as a negative. If we do 8 plus negative 3, that gets me 5. If you look at this one, negative 6 plus negative 2 gets me that negative 8 that we wanted. And then on the original problem, the first one, if I did the 8 plus 2, I get 10. So you're looking for two numbers that add up to the same value and two numbers that have the product of the same value.